Alright, in this video, we're going to go over an example of sketching a polynomial. And the problem that I have is negative x to the fourth plus x cubed plus 2x squared. So in order to graph this, the first thing that we need to go over is end behavior. And end behavior depends on two things, the leading coefficient and the degree. So we're going to make a table. So for the degree, we can either be even or we can be odd. And our leading coefficient can either be positive or negative. Positive or negative. And depending on which combination of degree and leading coefficient we have, that's going to affect our end behavior. So if we have an even degree and a positive leading coefficient, we're going to rise left and rise right. If we have an even degree and a negative coefficient, we're going to fall left and fall right. On the other hand, if we have an odd degree and a positive coefficient, we're going to fall left and we're going to rise to the right. And if we have an odd degree and a negative coefficient, we're going to rise left and rise right. Rise left and fall right. So let's see which combination we're dealing with in this problem. So we have negative x to the fourth plus x cubed plus 2x squared. So if we think what degree means, degree is the highest power. The highest power in this polynomial is actually this fourth power, which is even. And the leading coefficient is the coefficient that's in front of the term with that highest power. So what is this coefficient? That coefficient is -1, which of course is a negative number. So we're dealing with a situation where we have even negative, which is this second case right here. So we're going to fall left and fall right. From there, what we have to do is figure out the zeros of this polynomial. So I'm going to write it down again. We have negative x to the fourth plus x cubed plus 2x squared. And it's kind of difficult right now to figure out what the zeros are, or the roots. So what I'm going to do is I'm going to factor it. I'm going to see what do all of the terms have in common. I'm seeing an x to the fourth here, an x cubed here, and a 2x squared here. So one thing that they all have in common is an x squared, so I can bring that out. And then just to make life a little bit easier, I'm also going to bring out this negative sign. So I'm going to say I'm bringing out a negative x squared, and what am I left with? Well, if I bring out a negative x squared from a negative x to the fourth, I'm left with an x squared inside. If I take a negative x squared out of an x cubed, I'm left with a negative x. And if I take a negative x squared out of a positive 2x squared, all I'm left with is a negative 2. And now this is a lot easier for us to factor because this is just a quadratic equation. And there's a lot of ways you can factor it. You can use the quadratic formula, but I think that the easiest way is just to see what multiplies to negative 2 and what adds to negative 1. And the correct answer would be positive 1 and negative 2. So that's exactly how we're going to factor it. So we're going to say negative x squared, and then x plus 1, x minus 2. And now all we're going to do is set each of these terms equal to 0 and get our roots that way. So I'm seeing this negative x squared. So obviously, in order for that term to be 0, x has to be 0. But I'm seeing that there's this 2 here, which means it's a double root. So it's actually 0 and 0. X plus 1, in order for that whole parentheses to be 0, x has to be negative 1. And then for x minus 2, x has to be positive 2 in order for that parenthesis to be equal to 0. And so we have our roots. We have roots, or zeros, depending on whatever you want to call them. We have 0, negative 1, and 2. And then we have to look at something called the multiplicity. And the multiplicity is how often that root appears in the problem. So how many times does 0 appear? Well, we have 1 and 2 zeros. So the multiplicity is 2. Negative 1, we only have the one negative 1, so that appears once. And 2 also has a multiplicity of 1. Now, if we think about what the multiplicity means in terms of graphing, well, an even multiplicity means we're going to bounce. And an odd multiplicity means we're going to cross. And when I say bounce and cross, I mean behavior at the x-axis. So we're either going to bounce off of the x-axis or we're going to cross through the x-axis. So what I have down here is just a graph, and we're going to sketch the function now. So I'm going to rewrite everything that we found out just so it's all in one place. Again, our roots are 0, -1, and 2. Multiplicity of those roots is 2, 1, and 1. And the behavior, so again, even multiplicity means bounce, and an odd multiplicity means cross. So -1 and 2 both have a multiplicity of 1, so they're both going to cross the axis. And finally, if we think back to the beginning of the video, we found our end behavior. End behavior, we said, is going to fall left and fall right. So that's everything that we need in order to graph this. What I'm going to do now to start graphing it is I'm going to put points on the x-axis for 0, -1, and 2. So I'm going to go 0, -1, and 2. And now I'm going to look at my end behavior. So we have written down here falling left. So I'm going to go to my leftmost point, which is -1, and I'm just going to fall down from there. Now, a question that gets asked a lot is, how do I know to fall down like that, or like that, or like that? And there really is no good answer. You don't know what the end behavior looks like exactly. All you know is that it's falling down. To get a more precise answer, you either have to use a graphing calculator or you have to plug in points, neither of which are relevant for this type of problem. In this type of problem, all we're doing is our best guess. So if I know that it's falling down, I'm just going to make a curve that kind of trends downwards. Same thing for the right. I know that I'm falling to the right, so I'm going to go to my rightmost point, which in this case is +2, and I'm going to fall downwards there. Now, if we start at that 2, we have two options, right? We can either continue going up, or we can bounce off the axis and go back down. Well, let's look at our behavior. We know that at 2, we have to cross the axis, so I'm going to go up from there. Same thing at -1. At -1, we also have to cross, so I'm going to go up from there. Now at our behavior at 0, we have a bounce. And we know that this curve has to go through 0. So if I, for example, curve downwards and hit that 0, again, I have two options. I can either keep going down or I can bounce up. But since we know that we're bouncing, I'm going to do the latter. And I'm going to bounce up from there and just reconnect it with the other curve, the other half of the curve. And that's it. We're done the problem. This is a sketch of what -x⁴ plus x cubed plus 2x squared would look like. Again, do we know that it's exactly like that, or does it kind of do one of these? We don't really have a good way of knowing. We're just estimating. But for the purposes of this problem, this is a perfectly valid answer. I hope you found this video helpful. If you have any questions, please let me know. Thanks for watching.